All right. Yesterday we covered two different apportionment methods. The first one was Hamilton, and remember what we did is we took the quota that we got, rounded it down to the lower quota, and then whatever was left over, the extra ones, that we awarded to the ones with the highest decimal in their quota. Remember that yesterday? And the other one was Jefferson. Jefferson, we had a trial and guess with finding a standard divisor or modified divisor for Jefferson. And then we would round it down to the lowest quota and then add it all up and hope that it would equal the allotted amount, right? Okay, so that was Jefferson's method. Adams' method is the mirror image of Jefferson's method. So what we're going to do is guess and check for a divisor again, but this time we're going to round it up to the upper quota and add it all up and hope that equals our allotted number. Okay, so what you guys need to write down here for the note is you're going to begin with a modified divisor that's slightly greater. Than the standard divisor. Okay, so our standard divisor, continuing from the same example that we've been doing the last day, was 20. Okay, that's what we used yesterday. And it says we got to pick one that's slightly larger than that. So I like to keep to the 0.5 to start with. So I'm going to start with a modified divisor of around 20.5 and see if that works for us. Okay, so if we use 20.5 and we divide 138 by 20.5, we end up with getting an A value of 6.7, a B value of 12.9, a C value of 26.02, and a D value of 32.29. Okay, so now that we have this modified quota, we are going to actually round them up. Okay, so 6.7 is going to become 7, 12.9 becomes 13, 26.02, that still becomes 27. Even though it's super close to 26, right? Because we're rounding up no matter what. 32.29 becomes 33. If you add all those together, you do end up with 80. So this is going to be the numbers that we would allot using Adams' method. One of the things that I need to go over really quick with you guys too is it says that sometimes Jefferson and Adams disobey the quota rule that we talked about yesterday. They go outside those boundaries. And this is called, when Jefferson goes above the upper quota, this is called an upper quota violation. Okay? And when Adams goes below the lower quota, that's called a lower quota violation. Okay? In our cases that we showed you today and yesterday, they didn't actually they didn't break the quota rule, but they can. So I just wanted to bring your attention to that. It might happen in your homework. I don't know. So the last one that we need to talk about today is Webster's method. And somebody brought up the fact, why, when we are rounding, why don't we round like we've learned since elementary school? When you're at 0.5 or above, you round up, and if you're below that, you round down. Well, Webster does that. Okay? He's the only one that rounds normal. Okay? The only thing that's different about him, though, is his modified divisor. Once again, it's a trial and error. It's a guess and check. But you can his divisor, whoops, divisor, is either any of the following. It could be slightly greater, it can be equal, or it can be slightly less. Than the standard divisor.
Question.
Mm-hmm.
See the guy that wrote the dictionary?
Daniel Webster? He didn't write it. He might have been named that.
So you have a lot more possibilities for a divisor, and therefore you might have to do more guess and check with Webster than you did with the other two. I'm going to go through a couple of possibilities here. We remember that our divisor on this was 20. So I'm going to start off with a modified divisor of 19.75. It's just I'm randomly picking something out of the air, just trying to see if it'll work. Okay? So 19.75. And we know it's got to be somewhere surrounding 20. It can even be 20. It might be. Okay? So if we divide each of these by 19.75, we get an A value of 6.987. We have a B value of 13.46, a C value of 27.03, and a D value of 33.51. So now this time we are going to normal round it. Okay? So this was the modified divisor that we came up with. Okay? 19.75. This was the modified quota. So rounding this one, this would go up to 7. How about this one? 13. Good. How about the next one?
Actually, no, would it go to 13?
Yep, it goes down because it's a 0.4.
So the 6 makes it.
But that would be double rounding it then. Okay? C is 27.03, so we're going to go down to 27.
34.
And this one would be 34. So if you add all that up, you get 81. So that one's not going to work for us. We need it to equal 80. So let's try divisor of, let's just try plain old 20. Okay?
Normal rounding up.
Yeah, if it's a 0.5 or greater, you round up. If it's less than 0.5, you round down. It's what we've always counted as rounding.
That's the Jefferson method?
Jefferson method rounds down no matter what. Adams method rounds up no matter what.
And Webster's
what about the
Hamilton, it rounds down, and then you take your 2 extra ones, and then you apportion them to the ones with the highest decimal point in their standard quota.
What's it again?
Jefferson takes, he rounds down, and then however many seats you have extra,
No, that's Hamilton.
I mean not Jefferson, Hamilton takes, rounds down and takes whatever seats you have extra, he apportions them to the standard quota with the greatest decimal point. So like 6.9, that person would go up. Okay? Okay, so let's try 20 here. 20 we get, for a value of A, we get 6.9, 13.3, 26.7, and 33.1. So we would round up here, 7. This would round down to 13. This one would round up to 27. And this would round down to 33. And if you add all that up together, we get 80 this time. So we can stop. All right? I will tell you that I did try divisor equal to 19.9, and that also worked. Because it ends up giving us the same numbers as this. So you can have a divisor. You could choose a divisor, more than one might work.